Accretion in a blast furnace is a significant operational challenge. It disrupts its operation, causing inefficiency, downtime, and material losses. To effectively prevent accretion, it's crucial to address the underlying preconditions that led to its formation. We will start by looking at how to optimize burden quality, which is the foundation for smooth blast furnace operation and helps prevent a scaff, or we can say to the specific scaffolding. Now coming to the slide, which is about optimizing burden quality, and it also shows that why optimizing burden quality is a paramount. First, we must minimize fines content. Excessive fines, meaning particle less than 4 mm in ore or 8 mm in coke, significantly reduce permeability. Now, this led to gas channeling, temperature imbalances, and localized burden cohesion. Regular burden screening is absolutely essential. Second, enhance burden strength. Weak burden tend to break down during descent, which increases the amount of fines. Ensuring consistent material strength through proper selection and beneficiation is the key. The third is to stabilize raw material composition. A consistent chemical composition ensure a stable thermal profile, which is vital for maintaining the quality of both slag and hot metal. Variability in composition can lead to uneven melting zones and an increased risk of accretion. Finally, control alkali and zinc content is also very important. Alkali metals, especially K2O and Na2O, should be kept below 3 kg per ton of iron, as excessive alkali can destroy the burden and refractory lining. You can manage these levels by using low alkali ores or through periodic desulfurization. Similarly, maintaining zinc content below 0.15 kg per ton of iron to reduce its destructive effect on both the burden and the furnace lining. So we must have to note down this alkali optimum requirement, the zinc, all is to be noted, and in day-to-day operation these are to be strongly built in the practices incorporated in the SOPs. Now, next, let's discuss maintaining gas distribution and monitoring permeability. Balanced gas flow is critical because it ensures even heat distribution and smooth burden descent, thereby preventing scaffolding. Avoid heavy peripheral burden. Overloading the furnace wall during startup or operation can cause uneven heating, scaffold formation, and damage to the tuyeres. Conversely, prevent excessive central burden. A light periphery combined with a heavy center also led to irregular burden movement and scaffolding. It's essential to ensure reasonable stock permeability. This means adapting the blast volume to the stock condition to prevent channeling, uneven burden descent, and scaffolding. Maintaining proper blast volume and permeability balance is critical for smooth furnace operation. So our recommendation include, when burden strength decreases or fines increases, you must reduce your blast volume to match the stock column permeability. Crucially, avoid overblowing in pursuit of higher output. These practice causes scaffolding and long-term inefficiency. We can learn from historical cases such as Ukraine and China's post-war operations, where overblowing with poor raw material led to severe scaffolding. Activating hearth condition is another vital area for preventing accretion. A well-maintained hearth is essential because it ensures uniform burden movement and gas flow, which directly helps prevent scaffolding. Here are the key actions. Prevent hearth accumulation by promptly clearing any blockages or debris. Avoid prolonged plugging of tuyeres. These disrupt the crucial circular uniformity of the hearth. If plugging is unavoidable, use a small tuyeres or temporary sleeves and limit the plugging period to a maximum of 20 days. Now coming to the smooth operation, and which is supposed to be a key to eliminating a scaffolding risk, we can say, especially when dealing with subpar raw materials. Here are some guidelines. Avoid frequent channeling. Channeling often caused by excessive fines and high blast volume. Destroy operational stability. Reduce the blast volume promptly in such cases. Operate at standard stock line. Lower stock lines can lead to burden, re-condensing, and accretion formation. Ensuring proper stock levels are maintained helps stabilize the top temperature and prevent zinc condensation at the offtake. Finally, when you handle high alkali burden, do so carefully. Reduce slag basicity regularly to remove accumulated alkali metals. So remember also, for smooth operation also minimizes alkali damage to the burden and the lining. So now coming to the preventing water leakage is a also very important. It's a critical measure. Water leakage into furnace causes burden recondensation, directly leading to accretion. Here are the preventive measures. Damaged coolers should not be isolated completely. Instead, use low pressure artesian flow to supply cooling water while being extremely careful to avoid any leakages into furnace. Properly manage cooler maintenance. This involves stopping the water supply during furnace shutdown and restarting it before blowing it to prevent cooler burnout. So, in conclusion, preventing accretion requires a proactive and strategic approach. This strategy integrates three key areas: raw material optimization, operational adjustment, and regular monitoring. Historical lessons consistently highlight the importance of achieving a balance between raw material quality, gas flow, and operational discipline. By diligently addressing all these factors, blast furnace can achieve enhanced reliability, longevity, and productivity.